Assalamu alaikum warahmatullahi wabarakatuh. Welcome to Hasib Electronic. If you are visiting first time to my channel, after watching this video, if this video is good for you, you can like, subscribe, share. And if you want to watch my future videos, you can hit the bell icon button. If you have any question, don't hesitate to write in the comment box. So today I am going to demonstrate how you can troubleshoot power supply. Every circuit, the basic requirement is power supply. The design of power supply may be different, size of power supply may be different, but the function is always same. Today I will demonstrate step by step. So take care for safety. It is a power supply circuit. It is very small. It takes 220 volt and it gives us 5 volt regulated. How is the circuit? We will see step by step. Here are input terminals, AC. The two terminals here are AC input. If we see the one line, it is here, and this line is going to this filter capacitor, and the other side is going to this inductor. Inductor is divided into two pieces. It is entering in the first coil. Then we will see the second line. The second line is here, AC2 terminal. If we see AC2 terminal, AC1, AC2. AC2 is going here and AC1 is going to fuse. Here is fuse. After passing this fuse, it's going to inductor second end. The first coil, the second coil. These are two inductors in line. If we see two inductors, the one line is connected to, this is inductor, one side is second side, one side the second side. Okay, here we have two terminals here, we will see what is there. Its input 90 volt to 265 volt and 50 hertz, 60 hertz, and output is 5 volt, 2 ampere. This converter, it is very useful. It is a standalone power supply 5 volt. As we are discussing, two lines here, these are bridge rectifier. If we see this line and this line, these four components, two lines and two lines connected here. After passing this bridge rectifier, it is coming here, and after passing this line here, I will connect AC line here. You can repair any battery charger, mobile charger, any power supply in the same way. There is no difference. If you are working on a power supply of computer, working on power supply of laptop or anything, the same idea. There is nothing change. Just only we can say the size may be different, but the working principle is always same. So I will connect the one line which is input terminal for AC, and always when you are making connection, don't make any loose connection or long lines. Connect power. What we will do, we will check voltage here, AC voltage. Here we will find AC voltage, after capacitor AC voltage. At the bridge rectifier, these two lines are for bridge rectifier. Until here we will check AC voltage. After that, at capacitor we will find about 300 plus volt DC. So now let's start. If you have any question, please let me know in the comment box. We will set it to AC. I set it to AC voltage, and we will check AC voltage here. Carefully, never touch the line. It is 236 volt. Now we will check the output of the fuse. We will put one line at common, one line, and the second line here, and it is second line here at the after and output of the fuse. After fuse, it is coming two lines coming, the main line coming here. It's about 236 volt, and after that, after passing this coil, if we cannot find voltage here, that means the fuse is damaged. In this line, there is only one fuse. If you cannot find voltage here, the problem is fuse. Okay, after passing this coil, the voltage are here. If you cannot find voltage here, the problem inductor, change the inductor coil. After that, you can find voltage at these two terminals. At 236 volt, that means the input of bridge rectifier is okay. After passing from bridge rectifier, we will find the output of the bridge rectifier at the capacitor. So the capacitor, it is DC, and the output of the bridge rectifier, that is also DC. So you have to switch the multimeter to DC voltage. And now we will check very carefully. It is 336 volt DC and stable. If these voltages are not stable, that means the capacitor is bad. Now we will check the output. DC voltage. We are facing problem. The voltage are not stabilized. The voltage are not stabilized. If the output voltage, if we have some voltage here, that means the output of the transformer that have problem. It is not giving any proper feedback signal to this area. After this capacitor, there is a inverter circuit which makes chopping. Here is DC voltage. These DC voltage, I will show you how it is working. This line is directly, positive line is directly going to transformer one end, one pin. Positive line is directly applied to transformer. And the negative line, if we see this negative line, it is going to FET, field effect transistor. So field effect transistor, it will make switching. When the signal at the gate will appear here, it will cause to switching to the FET. Now how we can find the switching? The very easy and the best idea, very easy. It is very easy. You can find DC voltage here, 336 volt. It is a very key point. It is making switching. How we can find? You can find AC voltage at the pin 3 and 4. We can find it is working, but it is not giving a proper feedback. So we have to check this portion. At pin, these two pins for transformer switching and these two pins for the feedback. Connect multimeter and we can see voltage are varying. 150 millivolt, 150 and 90. It should be stable. Every circuit, it have different voltage level, but it is switching. It is not proper way switching. So we will check what is the reason of this issue. If the output circuit have short circuit, any item, any component is bad, we will find problem in this area, like this. If there is no switching at all, the problem in this area. If there is switching but the voltage are not stabilized, the problem in output area. Now we will check step by step. So now I will check. First of all, I will check capacitor, the output capacitor. Sometimes it is short. Sometimes the output capacitor is short. I will remove it. I remove the capacitor. When you remove the capacitor, always take care of the polarity. I have capacitance test facility, so I will put at ohm and then yellow button. Now I am in capacitance mode. First of all, make 2 pins short of the capacitor to discharge it. Now I will connect the multimeter. It is 473 microfarad. I will read it is 470 microfarad. So this capacitor is good. It is 470, and when I will connect multimeter, it will give me 471. That means it's very close to, it's okay. So this capacitor is good. When you connect the capacitor, polar capacitor, always take care for polarity. Never connect the opposite side, reverse polarity. If you will connect the reverse polarity, it will damage immediately. Never connect polar capacitor in reverse direction. Then we have another capacitor. We will check this capacitor also. What's its response, because you cannot check the capacitor in circuit. I am using Weller desoldering gun. It is very useful, Weller WR3M. It is my favorite test equipment, workstation. Weller is my favorite rework station because it never damage the PCB. Now I will make short the two pins. When you test capacitor, always make short the both pins. It is 1135 microfarad. So if I see it's 1000, so this capacitor is also good. Now I will connect it again. Service engineer, if you are working in a firm, so never compromise on quality. Then there is a capacitor and a resistor. We will check one by one. I will power on again. I powered it. DC voltage. I will check again. I have 330 volt here, okay, and here I have voltage at output terminal. I have voltage, I have output voltage, but these are varying, not stable. I need stabilized voltage. When it is not stabilized, what we'll do, rectifier section, filter section working, inverter section working, and output section making rectify, and the output at the output voltage terminal, that's okay. The problem in the feedback circuit, here's a KA431, that is intelligent, or we can say that's Zener. This comes in a transistor shape. How will you test it? In any two terminals, just 1 minute, I will, because it is power on, so now it's okay. At center pin and right side, center and right side, it is varying voltage, so it is not making a good reference. Center and left, it is changing, center and right changing. That means there is a variation in the input voltage. We will check the optocoupler. If the optocoupler pin number 1 and 2, the output side, it is not stable also, it is varying, it should stable, okay. The reference diode, the Zener, the KA431, that is working. Now we will check the output section. We can see output section is varying, it is not regulated, not stabilized. So we will check. That means the optocoupler is working. When here is voltage, the output is working. So that means optocoupler, the Zener, these are okay. The problem in this area, optocoupler output area, I remove the power. What is in the output area? In output area, we have, now here, I have one KA431 regulator, Zener. Pin center pin and this pin 1 or 2, how is KA431? This comes KA431 like this. It is in this package. Center and right, center and left, it is a reference diode. It is a reference. So we need to check it. How we can check? We have to check the center pin and the right, center pin and the left, voltage, DC voltage, and now at the opto isolator, pin number 1 and 2, we are measuring voltage. These are fluctuating voltage. Why? The fluctuation is due to regulation. The output pin, that is also changing voltage. Okay, we have a problem in this area now. Might be, we will check, there are 3 components: a diode, a picofarad capacitor, a capacitor, a resistor, and this capacitor. So resistor is looking good. So most of the time the diode is okay. The diode is okay. We will check this capacitor. The polar capacitor, sometimes due to high voltage spikes, these capacitors make problem. So we will remove this capacitor. I will remove this capacitor now. I removed it. First of all, make the both leads short. Move to capacitor. Switch it to capacitor, microfarad, and oh wow, this is bad. It is giving 25 microfarad, even it is 47 microfarad. It's 47 microfarad, but on the multimeter it is giving the low value. So this capacitor, you can see it is giving 25 microfarad. It's 24. So I will take another capacitor, the same value. Forty-seven microfarad, 50 volt. I will take the same value, and now I will check. Oh, it's 45 microfarad. This one is giving 45 microfarad, so I will replace this capacitor. The original one, it was giving 25. So this capacitor is not good. I will install this capacitor. Always take care for polarity, because for polar capacitor you need to special care for polarity. So here is a negative sign mark on the board. So I will connect negative to negative and positive to positive, and we will connect it. Most of the time there are small problems. The capacitor was looking nice. There was not looking anything. It is not no short circuit or nothing, and no anything, but just we have to verify, test it with the multimeter. So now it's okay. I replaced it, and I will check the. Now I installed this capacitor. We removed this one, 47 microfarad. Now I will check DC voltage, and I will check the input of the optocoupler. Wow, it is stable. 1.6. Before this it was moving, it was fluctuating. Now it's okay. And the output, that's also 0 volt DC. That means it's working. So we will check the output. Take care, it is alive. We have fixed voltage out in the output, 5.1 volt. So we solved the problem. If this video is good for you, you can subscribe, like and share. Because power supply, we have 3 sections: input filter, rectifier circuit, inverter circuit, output circuit, and between output there is feedback. This goes to inverter section. If there is any problem in this area or the feedback circuit is also faulty, so this section will not work. Now this converter, this buck converter is working properly, 5.1 volt. We solved the problem. We found this capacitor, the value, it was down, capacitance decreased due to, sometime it becomes due to internal shortage, 25 microfarad. We will see why it is. Wow, it is discolored. We will find the reason. What was the reason for failure? Oh, it is internally short. This capacitor, if we see, there is a leakage between 2 plates. So due to leakage, this is discolored. The color changed due to sparking inside. This was the reason. The internal insulator of the capacitor, it was short circuited. Between this insulator becomes in these 2 plates, this plate and this plate, this metal and this is metal, and this is insulator. If we see this insulator, it have bad color. So it was the reason to making fluctuation in the voltage. I think this video is good for you. If this is good, you can like, subscribe if you want. Thanks for watching.